Alrighty, happy Monday. We're moving on to new stuff. Yay, everyone's excited. Exceptions and modules is actually pretty quick. There's not a ton of material here, so it'll be pretty light. We'll have more time to get caught up on Project 3. Should go pretty well, I think. So we'll get through, I think, all of exceptions and modules today. I don't know if we'll have much for Wednesday, but we'll look and see how far we get. We can practice them for labs. Um, and then Zybooks for 10 and 11 that'll be due next week. Let me go add those in. They're pretty short chapters. There's not too much here uh, for 10 and 11. I say short, but like 7 sections is pretty quick. Uh, so let me go add in those. Do you want them as separate assignments or you want them all as one? Well, it's like double the points if I do it separate. All right, so you want the points for them? Sure. So do chapter 10. Why not? Next week. And then 11. No submission. All right. Save. And chapter 12 or chapter 11. And I think I offered you folks, if you want me to rescore a few chapters here and there, let me know. Just shoot me a message. I would just prefer not to rescore all of them. One, two, or three. Sure. I'm okay rescoring those late if they didn't get them in completely on time. But again, this is your incentive to keep up here. That's why we've got the due dates. And hopefully that's going well for you here. I don't have anybody saving all of it for the last week, for finals week. That seems miserable to save Zybooks for finals week, but you know. And we've got our next lab coming up here. Very exciting on exceptions and modules. So let's start with exceptions. Exceptions are fantastic. So far, when we wrote our classes here, and mainly this relates to classes and some functions here. If something didn't go well, we just didn't make the value bad and kind of ignored it, right? Like for setting my, oh, not that one here. Oh, a different one. Recent. Uh, do I not have that one? Where did I put it? Oh, I think I opened it in the other version of PyCharm is why. GitHub 1501. I got too many of these repositories. I got to clean these up here. Chapter 9 classes. There we go. All right, I just want to open that folder. No. Oh, having a rough time here, guys. Sorry. Try that again. Documents, GitHub 1501. Chapter 9 classes. Select folder. Okay, there we go. I open the whole folder. Now it will look a little better here. So, if we wanted to, say, change the height of a chair, we just said, "Nah, you wanted to go way too high? I'll just stop at the max and not say anything about it." That's an option here, but it might be nice to tell the person who tried to do that, "Hey, you did a bad thing," and then make them go fix it, right? We don't have a way to do that right now. So, like, if we try to convert a string to an integer, and it's not a number, Python pukes on us. We get an exception. So we're going to learn how we can use exceptions in our classes to make the person trying to do a bad thing fix it themselves. Right? So what we can do, we can check and say, hey, if we went above the max here, well, and we can still stop at the max if we want here, and then we can say throw, or I'm sorry, raise. Uh, is it a value error? We'll say invalid height. Right? So we can use this raise keyword, or somebody zoom that in here, to raise our own exception. So this says, oh, hey, person who called this function here, they tried to change height here, they have to catch this or crash, right? Oh, okay. So now I'm going to go try and change my height here. It crashes on it when my test doesn't pass here because I got a value error. It's not working the way we expected it to, right? Which is okay, right? It's not the end of the world here. So what we're going to do is when we go and change our chair heights, we're going to run not the test here. We're going to run this one here. Let me run this file. We run main here. I also had lotto tickets. Is that what I did here? Yeah, I did. All right. Hang on, I want to do just the chair stuff. Comment that for a second. So all the changing was fine here. Let's go change too high then. Let's change that to like 500 here. And now we get, oh, it crashes on me. So invalid height was the message we gave it here. It says, hey, it crashed at line 58 in change height. That came from line 84 when you tried to change height by 500 in Jubilee's chair, right? So we're reading this, they call this a stack trace here. This is where this function was called, and this is where this function was called from. And this can go pretty deep, right? If we have functions that call functions that call functions that call functions, it's going to go kind of deep. But we'll see, hey, we had an invalid height. So what we can do on the side that calls the function is we can make it not crash. We can use something called a try block. We're going to say, hey, this might cause an exception. I want to try it. And if it causes an exception, let's do something different here. So we're going to take all of this, because I know that function might do that. I'm going to put it in a try block and say, let's try this. And then if it doesn't work, I can say, hey, I want to grab that exception here. We'll just call EX here. Oh, exception. Oh, shoot, hang on. It's value error as EX. There we go. And it says, hey, if a value error exception happens, let's call it EX or exception. Right, why not spell it all out here? Exception here. And then you can just print the exception if you want. Now, this isn't going to make it not, it's not going to make it work, but it's going to make it not crash on me here. So when we get that message here, we're saying invalid height. Didn't change the functionality here, but what it lets me do is if the person who's calling this function wants to do something about it, they have that option too. Right? So now at this point, this was just hard coded in, but maybe I wanted to ask the user, hey, you enter the value of how high we should change it. And if an exception happens, we can tell them, hey, that number was bad, try again. Right? So maybe we ask, we get some input here. A change is an input of, or an int of an input, how high or how much to change the height by, right? And then we can try that by the change, right? And if an exception happens, we'll tell them, hey, a bad thing happened here, and we could wrap all this in some sort of while loop here. Uh, I don't know, while not changed, I don't know, changed is false. And then if the try block works, so if this line causes an exception, you jump right to the except block here. So we can say changed is true. And this line never runs if this raises an exception. So it causes it to jump to the accept block here. So if we put a breakpoint in and we run this one in debug mode, we're going to watch it jump. So if we want to change by 500 here, we're about to call change height. So I can just step over and it skips this line because an exception happened. So it jumps right to the accept block. It says, hey, you're about to crash. And our accept block says, no, please don't crash. Actually, do this thing instead. And we're going to tell them, hey, that was an invalid height. And our loop is going to continue going. Hey, that was invalid. Try again. And now, so if we get a valid value, like 50, we keep on going here. Was 50 invalid too? Uh-oh. Oh, because we actually did change it. Shoot. Maybe we make our code a little cleaner here. Let's go back to chair. So let's see if it's invalid first, right? Before we do any change. How about that? So let's check to say if the height in centimeters plus the change is greater than the max, then we just raise an invalid height, right? It could be or the self dot, or no, if it's less than as well, right? So that's if it becomes less than self dot minimum is less than the height plus the change. No, that's the wrong way. Shoot. Uh, if the min is greater than that and it's less than that, does that make sense with math symbols? I'm really bad at my math symbols right now. So the height plus the change, it has to be, no, no, this is bad. Okay, hang on. We'll just, if it went over the max, or we'll just do it as an or. If self dot height plus the change is less than the self dot min. There we go. So if we went over the max or under the minimum, it's an invalid height. If we didn't do that, then we can just go add the value plus the change. Right, oh, so we don't want to change first. So let's see, is it a safe value to change to? If it is, change. If not, we raise that exception. Okay. All right. Oh, goodness. What? Change. Change in centimeters. Change in centimeters. Invalid height. What? We broke it right away? Broke it right away. Like, oh, okay, because I took my. Oh, I had defaults. Okay. Oh, we went and set them. Oh my goodness. Yeah. Let's not do this. We shouldn't set them. Set private attributes here. That's ugly. Oh, come on. Highlight 2 lines. Comment them out. There we go. All right. There we go. So by 500, it is invalid. We get our exception. Try it again. If we try 50, it changes. So if it doesn't raise an exception, the try block continues as normal. The code keeps working like we expect. Change is now true, and that finishes. So some people might use a while true and a break. I guess it saves you 2 lines of code. You can just make it an infinite loop until you hit break. Sure. Again, I like to avoid breaks because I think they're ugly. That's all. I don't know if this is any better, but sure. So if it's important for our class to tell the person who is using it that you did a dumb thing, you have to fix it, we can use an exception, right? Now, for our chair, sure, we could just say, hey, you stopped at the max, you tried here. It's totally up to us when we're writing our class what behavior we want to implement. But exceptions are forceful. They make the person calling the function handle it or crash. So that's our way of communicating, right? We can't just print stuff to the screen because people can ignore it. Right? You can print out error messages all day long and people are just going to ignore them and just keep on going and pretend like they didn't see it. Or, in the big mush of output here, in the first time I tried it, I didn't even notice the invalid height because it was like 7 lines up, right? You might not see those sorts of things. So this is a forceful error. So this is the proper way for classes or functions to communicate that a bad thing happened. Right? We shouldn't let ourselves get put in an invalid state. Right? One of the jobs of classes, as we're encapsulating all those details, is to protect the integrity of the class. So you can't let your values get into invalid states, because then your warranty is void. Right? If you let someone change the private attributes, who knows what's going to happen? Right? You depended on them being certain values for it to function as advertised, and it won't do that if you don't. So we have this in our toolkit now. We can raise our own exceptions if they do a bad thing. So all sorts of checking here, like has arms. That's not very interesting here, but do we do like the shapes? Do we do triangles? No, we didn't do that one yet. We'll get to that one. So if you try and give a shape the wrong number of sides, we could raise an exception. Those sorts of things here, like, hey, you can't have 4 sides on a triangle. I don't know, some sort of things like that. Or if you're setting the lengths here, we know what valid lengths can be. It's an invalid length. So you have lots of options here. So like with our lotto tickets here, if we wanted to make sure that our numbers were valid here, right, when we did our validate numbers, where did that go here? We just set it to 0. That's probably not what you want to do with a lottery ticket. If someone picks a wrong number, you probably don't want to give them a 0, right? So this, we could raise an exception, right? So if the number's good, great. If not, we'll raise an exception, right? So we could do the opposite. We could return the number or raise an exception here. Raise value error. Number must be between 1 or 0 and 10, or I guess 10 is invalid. So between 0 and 10 must be 1 to 9, right? Something like that for our lotto ticket, right? So this is the forceful. We're going to make sure they know they picked a wrong number here, and it's on them to fix it or crash. Right?
This doesn't restart and have them re-enter it, does it?
So the person using the code has to go and do that themselves. So like our lotto tickets down here, we didn't do that here. We uncomment those. So when we ask them to enter a number, these are all random. So if we wanted to ask them to enter a number, we'd have to be trying the exception, right? Or catching the exception like we did up here. We'll say while It's not good. Keep on asking. Eventually, we'll get a good number. Um, so this gets to be, it's a little annoying sometimes dealing with exceptions, but it makes sure that we're getting the right thing that that class wants here and making sure however the class is being used, it's being used correctly. Because one of those ideas with classes is we want code that's so good and wonderful, we're going to reuse it everywhere. Right? It's portable, and it might not be in a console-based application. When was the last time you guys used a console-based application where you typed into a black box? Ever? Have you ever used an application in your day-to-day life where you just type into a black box for console input?
Yeah.
Rarely, though, right? Like that's not so.
Usually I'm trying to fix something stupid.
Yeah. So our classes generally won't just print stuff here, right? Our classes can be used in graphical user interface applications or in web applications or in mobile applications, right? Your phone can run Python. Your calculators nowadays can run Python, right? Who knows what kind of output they're going to have? So classes need to be independent of the input and output. Right? The goal with classes is they just represent that noun, right? They have all the details. We encapsulate all of the details. People can work with them abstractly with their public functions. Hey, I have a function for did I win money? Right? Is it a winner? That's my function. You pick some numbers, and I'll tell you if you're a winner or not. That's how you interact with the class. You don't need to know the details of it here because we're using that cool abstraction, right? So using exceptions makes sure we can protect that integrity. So if I run my lotto ticket bit here, let's see, uh, 50 was fine, and now we crash. We get an exception. Now this one is starting at line 109 here, and you can click it. It'll take you right there. It raised the exception from validate number at 101, from main at line 146. We picked random numbers. Oops, 10 is inclusive. Uh-oh. Right, that should be 1 to 9 here. 1 to 9, 1 to 9. Right. Thanks, random int, for being inclusive. And now, hopefully that one works here. And now we won here with 1,201 tickets. We finally got a winner. We would have had a bunch of zeros. Yeah. Yep. But we were doing it for our winning ticket as well. That should be 9. Um, so we just had extra possibilities. So we had 11 possible numbers for each digit then, right? Or no, one 10 would have been put down to 0 because we're taking 10. So it's still 10. It was 0 to 9 rather than 1 to 10. Okay. I don't understand the math. 1 to 9 is less than 10. I can count. There we go.
About the same. About like 20 tries higher. So
Yeah. Now, this should be a little different each time, right? Because it's pseudo random
Yeah.
here as we go. So we can use the exception. So the same idea now, without raising our own exceptions, we can do validation here if we're asking the user to enter some numbers here. Like, hey, you pick a ticket here. So let's say uh, first number Oh my goodness, it's an int of an input of enter a number 1 to 9, and second number and third number. Oh my goodness, this seems really dumb to do it this way, doesn't it? Let's just do like number. But now I need a place to store all of them. Oh jeez, I don't want to have to do this. 4 in range 3. Well, I want to validate them one at a time here. I think.
you gotta add S on number.
Yeah. So numbers is I'm going to store them here, uh, and then I can append the number here. But we can add this in a try block here because sometimes this crashes, right? If you give it something that's not a number value, it crashes on us. Was that oh my gosh, I don't even remember which one it is here. Is it a value error? As exception. Now, we don't want to add the numbers here. We want to do it if it didn't crash on us here, right? Okay, so this is while numbers dot length of numbers is less than 3. Let's just keep on doing this. There we go. Now eventually we get out three numbers here, 1 to 9, because if it crashes on us here, 50, enter a number 10, invalid literal for int 10, int with base 10, 10. So try again. Okay. How about now? 5, 4, 3. Now we picked out our ticket here, right? We got some numbers. Now I can make a ticket here, and then I can also validate that as well, right? So I don't know, is valid ticket is false, and while not is valid ticket, ticket equals ticket, lotto ticket given, numbers of 0, numbers of 1, numbers of 2, right? Because I'm only validating that it was an integer here, not that it was within range. This one validates that it's within range here. Oh, geez. Okay. So then we have, like, can do this inside of this one here, right? So I want him to pick numbers again, I guess. Yeah, yep. So we'll do this one here. We'll get all of them, and then we'll try and make the ticket, right? But this one then goes in another try block. Try this one. If it works, then is valid ticket. It's true. Exception, value error as exception. Print that out here. All right. So loop within a loop, right? So if it's invalid here, it never got set to his valid ticket, we go back, start over with three numbers again here, right? Seems like a lot of work, but we're checking it here. So 10 is invalid here. 12, it lets me take here, 13, 14. Oh, but now I get a number must be 1 to 9. Right, so now I can do 1, 2, and 3, and I get my lotto ticket. Ooh, 999. Wow, with 18 tries. Wow, we should actually go out and buy a lottery ticket, right? If we're going to win that fast. I've kept my streak alive. I've never bought a lotto ticket, so I've bought the scratch offs as gift for people, but I don't buy them for myself because I understand the mathematics behind it. Um, Even when I got up to like a billion, everyone's like, "Oh, you should buy one just in case you're going to win." I'm like, "No, you don't win money on the lotto." And I have not bought one because I'm keeping that streak alive now. It's been 20 years of not buying a lotto ticket, so it's not a bad streak, right? It's not impressive at all. It's just
I've won more money than I've lost.
I you are a lucky person. All right. So not only can we use our exceptions for our own classes, but we can also try and catch exceptions, handle exceptions from the built-in stuff that has crashed our programs before. So at this point now, we're able to make sure that the user doesn't crash my program by giving me garbage, right? I can recover from that crash, right, by handling the exception and let them try again. And they can keep on giving me garbage over and over and over, but eventually, hopefully, they give me something that's not garbage and we can continue on as intended. And that's the goal here. We want to sort of idiot proof our programs because people, not that they're idiots, but sometimes they're just not paying attention, right? Or they might think, oh, they want me to enter a number. I can spell out 10 because that is a number, right? 10, TEN is a number. Sure. Maybe they didn't understand you wanted the numeric values here. Why not? Um, I always like the joke that people put around there, like, "Hey, we asked a bunch of people at some sort of conservative political rally, should we teach Arabic numbers in school?" And everyone's like, "No." And you're like, "Oh, should we use the Roman ones instead?" Yeah, some people are just dumb. They just don't know, right? It's okay, and so we got to make our programs deal with that. Um, so handling exceptions is our way of doing that, right? All right, so this is our own raising exceptions. So we're going to add these for our lab today. We're going to be adding exceptions to our class, right, that we've written before, so we can make the person calling this function deal with it. You gave me something bad, it is invalid. I'm not just going to like silently ignore it or fix it for you. I'm going to make you fix it here.
Like 10, 11, 12 are greater than.
So the first input was just I want anything that is an integer. The only thing I was dealing with was if it's an integer here, I was going to take it.
Saying 1 through 9, that wasn't valid for this particular. So you had a function defined above that had different requirements.
Yeah. So
It wasn't relevant to this.
yeah, so
Okay.
this one is just checking is no, we can combine them here, but the way our lotto ticket works is you have to give it three numbers. So you have to prompt for three numbers. And we could validate on this side that the numbers are 1 to 9. The only downside with that is if at some point lotto ticket decides, oh, hey, now I'm the numbers 1 to 65 because I'm a Powerball ticket, we have to go change our input as well. Now, we still have to change our prompt anyway, so it's not really a great argument here. So if you can do some basic validation ahead of time, it's better. Exceptions are technically slow because they mess with the regular execution flow of code. It takes longer to deal with exceptions because like weird stuff happens behind the scenes. For our purposes, we're not going to notice because we're still dealing with user input here, but we don't want to like rely on these exceptions here and generate random numbers like and just be like, oh hey, let me just generate a random number 1 to 100 and I'll throw out 90% of them. That's going to slow my program way down dealing that way, right? Going through that exception flow. Um, so there's you can kind of think of this like this is the server side validation in my class here, that making sure it's good here, versus the front end. I'm going to make sure you enter the right number before you even hand it over to me. So when you fill out forms online and it says, hey, enter a phone number, and it's like, that's an invalid format. That's the front end side. That's the JavaScript side of your website saying that was an invalid format. But when it gets to the server side, the server's still checking to make sure it's a valid phone number. It's like, is this 10 digits here? And if it's not, then it's going to puke. And so you're validating both sides because the server wants to make sure you don't give it bad things, but it's faster to check at the beginning here on the front side. So you'll get into that when you do web programming. It's lots of fun. I like web stuff. Uh, so that is our exceptions. Now, we briefly touched on modules last week when we said, hey, we need to go import stuff from another file. That's all modules are. Modules are Python files. So it lets us modularize our code and keep it separate here in different places. So a good practice is to put your classes in separate modules, separate files here, separate from the code that runs. Now, when I hit run here, I had a bunch of other stuff that was happening, and that's not really great because it'd be nice to just have the class code all by itself on its own file. Right? And then if I want to do something with it, then I make a file with some main and it will go and do something here. So what we can do is I can take my class code here and we're going to go put it in its own file. So I'm going to go grab everything from the class here and I can do refactor. Is it extract? Is it not? Move. There we go. Move to, this will be chair. And I want to refactor it. So it's going to make a chair file for me with that code. You could make your own file here. I just was feeling a little bit lazy here. So this entire file, this module here, just has the chair class. Okay, that's all it has here. And over in main, if I want to use it now, I need to say, hey, I have two options. I can say import chair. This imports everything from the chair class, the chair module. Now I start getting some question marks here. It says, hey, it doesn't know what type chair is. So the problem with modules is it can have more than one class. And actually, sorry, this should be a lowercase here. Let me rename this one here. Rename lowercase chair. Right. So the chair class, it doesn't know where this is now because it has to come from the chair module. So when you use a module, it's module.className. Right. So like when we imported random, we said, hey, I want to use the random thing. It was, where to go? Random dot randint. So random is the module to be imported. Randint is the function in that module. So we can't just say randint. We had to say random.randint. Here's the module name. Here's the function name. So same idea now. So it'd be module dot class name. So chair dot chair. It looks a little silly here if you just use the regular imports. So that's why most people, like if you're just importing a single class, you say from chair, from the module, import the class name. Now I don't need to specify it's the chair. I can just say chair, because I said, hey, grab this thing from this module. Grab this class from this module. And we can do the same thing with random. We can say from random import randint here. And then I don't need to use random.randint anymore. I can just say randint. And it knows, hey, that's from the random module because you told me up above you want specifically random int from the random module. So if you like saving a little bit of typing here, you can specify at the top what you're importing, right? Either way works. So modules are nice because they help make sure that our code is separate. And then what I like about that is you can track the history in Git in your source control tools. So I can see the last time that particular class was changed, right? I think we looked at briefly, was it Microsoft's VS Code tool in GitHub? Right? There's 140,000 commits changes to this repository, this open source tool here. But you can go in and you can say, hey, I want to look at their extensions and I want to look at coffee scripts and I want to look at their syntaxes here. This file hasn't changed for 7 years. If something isn't working all of a sudden, it's probably not because of this file, right? As we're debugging, hey, some feature isn't working as we expected here. If this hasn't changed in 7 years, it's probably not the reason. But like, oh, hey, this thing changed. Oh, that's 9 months ago. Goodness, where's something more recent here? This one changed last month, right? Okay, so more recently, this file changed here. This one hasn't changed in 7 years. That's the ignore file. It's not very exciting. But you can go and see if you have separated all your code into different files, you can see the last time each file was changed. I think that's one of the big benefits of using modules there. Because then you just see, hey, this folder was touched 2 weeks ago. This one was an hour ago. Extensions changed. Oh, here, 1 hour ago, extensions. Where was it? Which one changed an hour ago? Where's all my... Is it not loading? Didn't load. Come on. Come on. Yes, there it goes. Which one was an hour ago? All right, it's not all that important, but you can track it down and you can see individually here. So a lot of people in Python land will put lots of classes in one file. I'm fond of one file per class. I'm a little weird here, and that's just kind of what I got used to. Um, it really doesn't matter. It's just style preference here, whatever you like to do. So if I wanted to go move my lotto ticket out, I can make another class for it, another module for it here, or I could move it into another location here. So I'm going to go refactor and move, or let's do this on my hand. So I'm just going to cut it out here. We'll go add our own file here, a Python file. We'll call this lotto.py, and I'll paste my class in here. That's, I guess maybe lotto ticket, right? Rename lotto ticket. Sure, lotto ticket.py. Now in main, I need to go from lotto ticket, import lotto ticket, right? From the module, import the class, and then my code works exactly like it did before. Now, when these imports happen, what Python is essentially doing is cutting and pasting that file into this line here. So if we have stuff, hey, like I wanted to play with my lotto ticket here, like all this here, I could put it in my lotto ticket file because, hey, I wanted to test my lotto ticket file. Oops, we need to import random here. Import random. Spinning tickets not defined. Did I not cut enough of it out? I didn't cut enough of it out here. Oh, this one here. More ticket stuff. Here we go. Lotto ticket. There we go. Random.random. Right. So, hey, I could run this one here and I could get all this testing code here. But now what happens here when I run my main file here, when I go import lotto ticket, let's see, did I just copy? Maybe I just copied it. I don't know what it's doing there. Why is it looking so weird? Let me move all this stuff over to chair here as well. Let's over to chair. There's like, oh, print chair was a function. Shoot. Man. All right, hang on. Comment those up for a second. All right, so main, the only thing it has is imports. There's like no code that runs here. But when I run main, it's like, hey, let's do some code, which is a little weird because when you import files, it essentially copy pastes that file in here. And if that module has code that runs, like chair has code that runs here, it's going to try and run when you import it, which is ugly. You probably don't want that. You really kind of only want this if you're testing out chair. So what you can do is there's this cool, remember when we talked about global variables way back when? There's this one called name here. So we can say, hey, if my name is equal to under main, uh, then I want to go do this stuff here. What that means is if this is the file that you're running here, its name is main. If you're running this other file and you're just importing another file, importing another module, then this file's name is main. The imported file is not main. Sounds really ridiculous. Yeah.
So goes off of which one is primary, primary.
Yes. Yeah. So if we put like a breakpoint in here, add a breakpoint here, and I want to debug main here. Right now, name is chair. So because this is the chair module. Over in my main file, its name is main because that's the main program being run here. Um, so it just happens to be named main.py. So it's cute that it matches. It doesn't have to match that. So PyCharm defaults gives you a main.py file. That's just it's a coincidence, right? They do it just because its name is main. It doesn't like we can rename this one anything we want here. So let's rename this one to how about not main here, and we'll add a little check here if name is equal to main print main. Right? Its name is main, right? It's not actually the module name when it's the file being run. Remember, all of that comes from when you tell Python, please run this file. Goodness, we did too many lotto tickets there. Up to the top, right? You say, hey, Python executable, please run this Python file. The Python file being started is main, is the main one, right? That's the source of where Python is starting. So that's the main file. Anything else it imports, its name is just the name of the module, right? It's a little awkward here, but we can follow along here. So what you can do, if you want to have code for just some quick little run, check your outputs here, because you're too lazy to write test cases, which is okay. Test cases are a decent amount of work here, and they're unfamiliar and new, and I'll forgive you. And I don't always write test cases because sometimes it's easier to just spit it out. That's okay, especially for demonstrating in front of you folks here. We can put code inside of this if name is main to hide it so that it won't run when we import. Right. But if I do want to run it, hey, I can say, let's run chair, and now I get, hey, let's change my chair height, and sure, it does the chair stuff that I'm expecting here. So to do the same with our lotto ticket, right? We protect this with an if name is main, name is equal to under main, right? And just drop all of this inside of that here. Now when I run my not main file here, it doesn't do anything. Right? I can import them safely here, and nothing happens. Right. So that's being able to use our modules. So I think that actually covers, let's see, handling exceptions with try and except. You can have multiple handlers. So if more than one exception can happen here, you can have different exception handlers for different exception types, like a value error or a type error. Like there could be more than one kind of error you can run into here. Value errors, zero division error, you can handle them differently if you want to have better messages here, which is nice. Or you can comma separate them, use a single handler. Right? If you want the same code or different code, you can do it that way. Let's see. Raising our own exceptions, we did that here. Exceptions with functions, yep, we did that one. We raised our own errors. The last bit here, you can have a finally block that does something regardless of if it worked or not. Right? So that finally block will do whatever you want it to do here. So finally, hey, let's go do something here. Like what's nice is like trying to close out the file. Right? Let's make sure we actually closed our file, regardless of if it worked or not. Right? We might have ran into an exception reading some value out of it, out of our file. So let's make sure we close the file when we're done. That's a nice thing to put in there. Um, You can write your own exceptions. This won't make a lot of sense yet because we haven't talked about it, but you can make your own custom exceptions. We'll come back to this later when we talk more about inheritance. But you can make a class that is a type of exception and do your own inheritance. If you want custom ones, I just use value error for like literally everything because it's easy. Sometimes it's nice to have a custom type here. All right, and then the labs for that one, awesome. And then for modules, There's a couple different labs. Oh, wow. Radioactive decay. That sounds fun. A modules themselves, right, is just putting things in different files. That's fun. Going importing. When Python goes to run a function, it goes and follows a certain sequence here. So it looks in the directory where the script is running. So, right, so when we run this program here, it's running, looking in this directory, right, for modules by name in this folder that it's running from. So it looks for files co-located, right, in the same folder here. Then it looks for anything set in the Python path. We don't typically do anything with this here, but you can add other places to your Python path. This is more advanced Python. I would not recommend you mess with this here to add other modules for importing. It's really complicated. And then it goes to look, hey, where's Python installed? So if we wanted to write our own random function here and we want to import random, we could write our own because it's going to go look in my folder first, right, and change what we're going to do with random. That's really ugly and messy, and I wouldn't recommend you do it. Probably going to make bad stuff happen. But Python path you can set as an environment variable. Other stuff here, it's not very interesting. Most of the time we won't do it here. Importing specifically, and you can import more than one thing from a file if you comma separate here. It imports everything or just imports certain stuff here. So imports. Make sure you hide the stuff with this name is main, right? If your name is main, we did that hiding. You can make a module reload. This one I've not seen to be very useful before, and it seems like if someone's relying on their module getting reloaded, they've done something wrong. That's just, seems a little odd here. So you can force it to reload here with the reload function here. In case something changed in the module, it's a little awkward here. I wouldn't worry too much about that one. And then packages are a folder of modules. It's a package. So I can put a bunch of modules, a bunch of Python files inside of a folder, and now it's a package, right? So in this one, hey, I want sound.music. Okay, here's sound, here's the music module, right? Sound.effects, here's the sound folder, here's the effects module, right? So folders become part of the import if you put stuff inside of folders as well, right? So you can separate them out here, right? So here's draw, here's your canvas, here's your man, here's your cow, here's your barn, here's your house, right? Sure. Right? We can have any sort of structure here for those here, and you can import specific ones or other pieces here, right? From ASCII figures, import cow. You can get right to cow. Otherwise, you have to use the dot dot, like this one dot this one dot this one, like so. Every module, every folder just becomes another something dot here, and you can go crazy with these. It's really just a preference. And then our standard library, right? All the cool stuff we can do in Python here is really fun. Like all these modules we've been using before, like the random module, the OS module, the sys module, math module. There's a time module. The URL lib is a really nice one for messing with URLs and doing web requests. We can play with this one later. There's lots of fun with it. All right, that's modules and functions. Real exceptions and modules. There we go. We got the right words here. So we can do our lab today. We'll do some custom exceptions here, or we'll do exceptions on our classes to make our classes raise exceptions, and we'll put our classes into modules when we write them, so we can go and import them in other files and deal with those here. That should take care of 10 and 11. Do you want to work ahead on Wednesday, or do you want to take Wednesday off? It's up to you folks. So we can jump into the next topic on Wednesday, pick up files early, or we could just take Wednesday off. Gonna take Wednesday off? I gotta vote for Wednesday off. Vote for Wednesday off. Okay. All right, cool. Yeah, so we'll just take Wednesday off, work on project 3. Let me know if you got questions about it. Happy to help. And then we'll pick up files on Monday the 10th. Then we'll do our lab on files. We got our project coming up due, right? I assigned it when I did the video last week, so it should be due on the 10th, right? So we can talk about the project 3 as well, right? Okay, that was our classes and testing project. So we covered the testing bit, which we have to write tests to make sure we got enough coverage of all the code that we wrote here. And we're just kind of eyeballing it. We're not using the tools you have to pay for. So like every if block, we're testing. right? And making sure that code runs at some point when I'm testing it here. That should be pretty good. Then we can get into our final project on the 10th to give you the whole month to work on it, essentially. We are almost done with new stuff, so files we'll spend a lot of time on. Inheritance we don't have to go super deep on because this is a big topic for next semester. And then recursion is another big topic for next semester. The Python for Data Science chapters, just here's some cool, fun stuff you can do, which is fun. Should be pretty good. And then we're closing in on the end of the semester, so we're almost done with new stuff, believe it or not. I think registration's open now, or at least they put out the schedule, right, for next semester here. So it should be fun. So far, it's going to be me. You'll be stuck with me again. My apologies. Um, and it'll be much more of the same at a different day and time. We're on Tuesday, Thursday next semester, and we have lab before the Tuesday lecture. So that actually works out nice. We'll do Tuesday, Thursday, but the semester starts on a Wednesday, so it'll be a little funky. We'll figure it out here as we go. Okay. Awesome. Well, I'll see you folks on next Monday then. Let me know if you got any questions. If you want to come and chat about Project 3, I'll be here next Wednesday anyway because I have my class beforehand.
There's no lab today.
And we'll have lab today on exceptions and modules.
Okay, okay.
Yep. Sorry. So after lab, I'll see you on Monday. Yeah, I'll see you in half an hour, 45 minutes, and then following Monday. All right. Thank you so much.